You know that feeling, right? You open up a fresh editor, you're ready to build something awesome. But what if I told you the most important part of coding happens before you ever write a single line? I know, it sounds a little backward, but stick with me. I'm going to show you the one thing that really separates the pros from everyone else. Let's get into it.
So think about your last project. Seriously, when you got the assignment, what was the very first thing you did? What's your immediate gut reaction? Let's be honest here. What was it?
If your answer was something like fire at my editor, well, you are definitely not alone. It's the most common answer, and it's also the most common trap. It feels productive, I get it, but it almost always leads to messy code, blown deadlines, and that sinking feeling of just being totally lost. Let me introduce you to someone who learned this lesson the hard way. So meet Rahul. He's a smart developer, and he just got a new gig, built a simple payroll app. Payroll? No problem, he thought. He'd done similar stuff before, so he just opened his editor and started banging out code, running on nothing but confidence and caffeine. I mean, what could possibly go wrong?
Well, pretty much everything. The app technically ran, but the numbers? All wrong. Tiny little miscalculations in the tax logic were causing massive errors down the line. Rahul then spent the next 2 solid days in a debugging nightmare, completely lost in his own code, second-guessing every single decision he'd made. That right there, that's the trap.
But what if there was a way to just avoid all of that? Well, there is. And it's not some secret hack. It's just professional discipline. It's a playbook that top developers follow to completely sidestep these kinds of nightmares. It's a simple process that forces you to build with absolute clarity right from the very start.
And here it is, the problem-solving life cycle. Now look closely. Step 1, analyze the problem. Step 2, develop an algorithm. Notice something, it's not until step 3 that we even think about writing code. Then, and only then, do we test. And finally, debug. The real magic, the part that saves you all that pain, happens in those first 2 steps. Now real quick, let's talk about these last 2 because people mix them up all the time. Think of it like this. Testing is your smoke alarm. It just screams, hey, there's a fire somewhere. That's it. Debugging, on the other hand, is being the firefighter who has to run into the burning building, find the source of the fire, and actually put it out. See the difference? One finds the if, the other finds the where and how to fix it. Okay, let's dive into that all-important second step, developing the algorithm. This is your architectural phase. I mean, you wouldn't build a house without a blueprint, would you? Of course not. This is the exact same idea. It's where you map out all the logic before you lay down a single brick of code.
So one of the best tools for making that blueprint is the good old flowchart. It's basically a visual map of how your program thinks. You use a few standard symbols, and you can literally see the journey your data takes, every decision your code makes, and where every single process is supposed to lead.
And the best part? You really only need to know a handful of shapes. Ovals are for your start and stop points. Parallelograms handle any input or output, getting data or showing results. Rectangles are your workhorses. They do all the processing and calculations. And maybe the most important one, the diamond. That's for your decision points, where your program asks a question and has to choose a path. But hey, maybe you're more of a words person than a pictures person. No problem. There's a tool for you too, pseudocode. And it's exactly what it sounds like. It's fake code. It lets you outline the entire logic of your program just using simple, structured English. This frees you up from worrying about all the picky syntax like semicolons and brackets, so you can focus purely on the logic. So, which one should you use, a flowchart or pseudocode? Well, if you have a problem with a lot of complex branching logic, a ton of if this, then that, the visual clarity of a flowchart is tough to beat. But if you just want to quickly bang out a straightforward sequence of steps, pseudocode is your best friend. Honestly, there's no wrong answer. They're just 2 different tools for the same job, building that perfect blueprint. And here's a perfect little example of pseudocode. Just forget about Python or C++ syntax for a second and just read the words. It's perfectly clear, right? You could show this to someone who's never coded in their life, and they'd get the logic instantly. That's the real power here, separating the what from the how. All right, so flowcharts and pseudocode are fantastic for problems you can wrap your head around. But what happens when you're staring down a real monster? A project so big, so complicated, you don't even know where to begin analyzing it? Don't worry, there's a strategy for that too.
So imagine your boss walks up and says, hey, we need you to build a complete school management system. And your brain just short circuits. You're thinking about student enrollment, attendance, grading, fee collection, library books. It's just way too much. The sheer size of it is paralyzing. Where'd you even start?
Well, here's the secret. You don't start with the whole system. You break it apart. You see, a school management system isn't one giant problem. It's actually a bunch of smaller, much more manageable problems all stuck together. You've got an enrollment problem, an attendance problem, a grading problem. All of a sudden, that monster doesn't seem quite so scary anymore. This beautiful little strategy has a name: decomposition. It is the art of taking one terrifyingly huge problem and just chopping it up into bite-sized pieces. Each of those little pieces can then get its own analysis, its own algorithm, its own flowchart or pseudocode. It's the ultimate divide and conquer for programmers. Okay, so now we have the whole playbook. We've got our 5-step life cycle, we've got our blueprinting tools, and we've got decomposition for the big stuff. So let's rewind the tape. Let's go back to our friend Rahul. How could he have used this playbook to turn his 2-day coding nightmare into, say, a 2-hour success story? Time for a little pop quiz. You've seen the 5-step path, and you know Rahul's story. So, which 2 critical steps did he completely blow past when he jumped straight into coding? You got it. He skipped step 1, analyzing the problem, which is where he would have found the correct tax rules. And he skipped step 2, developing an algorithm, which would have given him a clear plan to follow. By jumping straight to step 3, he basically built his entire house on a foundation of quicksand. All right, round 2. We know what steps he skipped. So how could he have done it right? What specific kind of blueprint should he have made to map out all that payroll logic before he wrote even one line of code? Exactly. A simple flowchart to visually map out the if this salary, then this tax bracket logic. Or even just some quick pseudocode to jot it down in plain English. Either one would have been his roadmap. And he would have caught his bad logic on paper in about 5 minutes, instead of finding it in his code 2 days later. And this, right here, is the whole point. Just look at the math. An hour or 2 of planning up front would have saved him 2 entire days of banging his head against the wall. That is a massive return on your time. The time you spend analyzing and planning isn't a delay, it's an accelerator. It's actually the fastest way to get to a finished working product. So there you have it. This playbook, it's not about some secret coding language or fancy trick. It's about discipline. It's about having the patience to think and to plan before you start typing. You now have the exact framework that the pros use. So the only question left is, what amazing problem are you going to solve with it?